Applications of differentiations. Stationary or turning points. A stationary or turning point is a point on a curve or surface where the gradient or derivative of the function is 0. A stationary or turning point can be either a maximum, a minimum, or a point of inflection. A maximum or minimum point is a point where the function reaches a local maximum or minimum value respectively. If the second derivative at a stationary point is positive, it is a minimum point, and if the second derivative is negative, it is a maximum point. A point of inflection is a point where the curvature of the function changes sign. A point of inflection can be identified by looking for a stationary point where the second derivative is 0 but the third derivative is non-zero. A graph of a function is given where this is a turning point and this is a turning point. At turning point, gradient is 0. To find coordinates of a turning point, put the derivative of the function equal to 0. dy over dx equals 0. In this way, you will find the x coordinate of the turning point. Substitute x coordinate into the equation of the graph to get y coordinate of the turning point. Worked example. A curve has the equation y equals x cubed plus 8x squared plus 5x. Work out the coordinates of the two turning points. At turning points, dy over dx equals 0. So d over dx into x cubed plus 8x squared plus 5x is equal to 0. Now differentiate it with respect to x. It will be 3x squared plus 16x plus 5 equals 0. Now solve it by factorization. It will be 3x squared plus 15x plus x plus 5 equals 0. Taking 3x common from first two terms, it will be x plus 5 plus 1 into x plus 5. Now x plus 5 is a common bracket. So take it out. 3x plus 1 into x plus 5 equals 0. So 3x plus 1 equals 0 or x plus 5 equals 0. From this x is negative 1 over 3 and from this x equals negative 5. Work out the corresponding y coordinates. When x is negative 1 over 3, y is negative 22 over 27. When x is negative 5, y is 50. So turning points are negative 1 over 3, negative 22 over 7 and negative 5 and 50. To classify which point is maximum and which point is minimum, find second derivative. Derivative of dy over dx or differentiate the function twice. Substitute the x coordinate of the stationary point in d square y over dx square to get a numerical value. If this value is negative, the stationary point is a maximum point. If this value is positive, the stationary point is a minimum point. If this value is 0, unfortunately, the test has failed. Go back and sketch the graph to check whether the point is maximum or minimum. Worked example is, a curve has equation y equals x cubed minus 3x plus 4. Work out the coordinates of the two stationary points. At stationary points, dy over dx equals 0. So d over dx into x cubed minus 3x plus 4 equals 0. Differentiate with respect to x. So x squared minus 1 equals 0. Now solve it for x. X is plus 1 and negative 1. Work out the corresponding y coordinates. When x is 1, y is equal to 2. When x is negative 1, y is equal to 6. Stationary points are 1, 2 and -1 and 6. Determine whether each stationary point is a maximum or a minimum. Give reasons for your answers. Find second derivative. Second derivative is 6x. Calculate the value at each stationary point. So for x is equal to -1, second derivative at this point is -6. So -1 and 6 is a maximum point because second derivative is negative. When x is equal to 1, second derivative is at this point is 6. So 1 and 2 is a minimum point because second derivative is positive at x equals 1. Examination tips is always read the questions carefully. Sometimes only the x coordinate of a turning point is required. Test yourself. Question number 1. Differentiate 6 plus 4x minus x square. It's a 2-mark question. Find the coordinates of the turning point of the graph of y equals 6 plus 4x minus x square. It's a 2-mark question. Question number 2. Find the two stationary points on the graph of y equals x raised to power 4 minus 4x cube. It's a 6-mark question. Question number 3. The diagram shows a sketch of the curve y equals x square plus 3x minus 4. Differentiate y equals x square plus 3x minus 4. It's a 2-mark question. Find the equation of the tangent to the curve at the point 2, 6. It's a 3-mark question. Question number 4. Y is equal to x raised to power p plus 2x raised to power q. dy over dx is 11x raised to power 10 plus 10x raised to power 4, where dy over dx is the derived function. Find the value of p and the value of q. It's a 2-mark question. Question number 5. Calculate the gradient of y equals 24 plus 5x minus x square at x is equal to -1.5. It's a 3-mark question.